Hi everyone. Today we're going to talk about the Marshall-Lerner condition. Many students have come to me expressing their confusion as to what is the Marshall-Lerner condition, when I can use the Marshall-Lerner condition, when I'm not supposed to use the Marshall-Lerner condition. There seems to be quite a little bit of confusion in this area. So today I thought I will make a short video to explain this. The Marshall-Lerner condition, right, is really a condition that is used to examine how a change in exchange rate will affect the balance of trade of a country. Now, to be clear, it has to be an exchange rate change to be the event, and the end variable that we're looking at has to be the balance of trade, which means the nominal value of x minus m. So the Marshall-Lerner condition, right, does not apply when we are trying to explain how a change in inflation rate, for example, might affect the balance of trade. So it has to be exchange rate change. At the same time, right, when exchange rate changes and we want to look at how X is changing or how M is changing or how aggregate demand is changing, where we look at the components of AD in terms of C, I, G, X, and M in real values, the Marshall-Lerner condition doesn't apply. So to be very precise, the Marshall-Lerner condition only applies when your event is a change in exchange rate and the outcome variable is a change in the nominal values of x minus m, or what is called your balance of trade. Now, what is the Marshall-Lerner condition? The Marshall-Lerner condition holds, right, when the sum of price elasticity of demand for exports and imports added together is equal to 1, is greater than 1, sorry. So when we talk about the sum of elasticities, we are dropping the negative signs. We're only looking at the absolute values. So if, for example, PED was 0.6, PEDX was 0.6 and PEDM was 0.5, for instance, then the sum of the two values will be 1.1, or more precisely negative 1.1. Then we say that the Marshall-Lerner condition holds. Now, in order to illustrate this, right, let's look at how the Marshall-Lerner condition works. Now, let's assume initially that the country's balance of trade is at equilibrium with another country, and suppose there was a 10% depreciation of the country's currency. So, taking Singapore and US dollar as just an example to illustrate this, right? Suppose the Sing dollar has depreciated against the US dollar by 10%. And again, we assume that the balance of trade between Singapore and USA was at equilibrium, so BOT equals to 0. Now, a 10% depreciation of the Singapore dollar would make Singapore's exports to America appear 10% cheaper in terms of US dollars. Now, this will cause the consumers in America to find Singapore goods more attractive, and therefore the quantity of exports Singapore's exports that Americans buy would increase. Now, to what extent will that happen? Well, let's assume a value of PEDX of 0.6, right? And you can see that a 10% decrease in the price in US dollar terms translate into a 6% increase in quantity of Singapore's export demanded by Americans. Now, but when I calculate the value of X, right, note that I have to measure this X value in terms of Sing dollars. So the PX here that we're using is not American currency, we're measuring PX in terms of Sing dollar. So the Sing dollar price doesn't change, but the quantity of exports increased by 6%. This tells me that total export revenue measured in Sing dollars rise by 6%. Now, let's look at the import side of the equation. When Sing dollar depreciates by 10%, everything that we buy from America will now become 10% more expensive. So price of imports in Sing dollar terms rise by 10%. And if we go by the assumption that the PEDM is negative 0.5, then quantity of imports will fall by 5%. Now, approximately, right, M will now rise by 5%, and as a result, X rises by 6%, M rises by 5%. If X and M were similar or very close to each other or equal to each other to begin with, then overall, the balance of payment would improve, or rather balance of trade would improve by about 1%. Right, so this is the way the Marshall-Lerner condition illustrates that when the Marshall-Lerner condition holds, a depreciation of a currency, ceteris paribus, will lead to an improvement in the balance of trade of that country. Now, the balance of trade of a country is measured in nominal terms, as I've explained earlier. What if we change it to real values? Suppose I want to know how AD changes when exchange rate change. Then the X value and M values we are looking at will all be real values, meaning that the prices we calculate will be base year prices. Now, looking at the same equations here, right, you'll find that both PX and PM, right, in real terms are not changing, right? Regardless of which currency you're measuring them in, they are not changing. So the only thing that determine what happened to X and M in real values, right, are the quantities. So when Sing dollar were to depreciate against the American dollar by 10%, for instance, then with American price of Singapore dollars becoming cheaper today, Americans are going to respond by buying more of Singapore's exports. Now, if you look at the real value of Singapore's export revenue using base year prices of yesterday multiplied by the higher quantities today, then the total export revenue in real values must increase. Now, similarly, right, based on the base year prices of yesterday, import prices didn't change. But today, import prices actually went up because of the depreciation. So as the quantity of imports decrease, then the real value, which is based on yesterday's base year prices, must also have decreased. So with X rising, M falling, the balance of trade will improve in a country when your currency depreciates. And this is true regardless of your elasticities, meaning that whether Marshall-Lerner condition hold or doesn't hold, in real values, this will happen. Now, that's not to say that elasticities aren't important. Right? Elasticities are still relevant in determining the magnitude of the change in aggregate demand. But as far as the direction of change in aggregate demand is concerned, then it really doesn't matter. All right, one last issue that students often bring up, right, is whether the Marshall-Lerner condition is applicable both for a case of depreciation as well as a case of appreciation. Somehow students have this impression that Marshall-Lerner condition applies only for depreciation and doesn't apply for appreciation. Well, that's not true, right? If you look at the mathematics of the equation, right, the Marshall-Lerner condition is symmetrical. Right? Where you depreciate the currency, then you will have a change based on the elasticities that affect the quantities as we shown earlier. Now, let's reverse this. Now, if you look at what is shown on the screen, right? An appreciation of the Sing dollar against the US dollar, assuming the same elasticities of PEDX of 0.6 and PEDM of 0.5, right, will show you that the price of Singapore goods in America will now become more expensive by 10%. American consumers are going to cut back their consumption of our exports by 6%, resulting in a 6% fall in the Sing dollar value of nominal X, right? Remember, Sing dollar value means that the price of Singapore's export measured in Sing dollar didn't change, multiplied by a lower quantity by 6% gives you a PX of Singapore measured in Sing dollar to fall by 6%. Now, at the same time, right, as Sing dollar appreciates, right, imported goods from America will be 10% cheaper in Sing dollars. Given the PEDM is 0.5, right, then our quantities will increase by 5%, and our M in Sing dollar again will current prices and not the nominal values of M will fall by 5%. This will suggest that your BOT will worsen by 1%, again assuming that we begin at a BOT equilibrium. So you can see mathematically, right, the balance of trade will worsen when your country's currency appreciates if your Marshall-Lerner condition holds. So the MLC is symmetrical. There is no reason to believe why the MLC only holds for depreciation and doesn't hold for appreciation. Right, so I hope that clarifies your concepts. If you have any doubts, right, please feel free to key into the comments below. And thanks for watching.